You don't know what you're talking about, Zinc. And you're not helping.
Hello, uranium, ruthenium, and zinc. What are you squabbling about this time?
Thanks for coming by so quickly, Xenon. I'm tired of hearing my sister and her boyfriend fight.
I wouldn't call it a fight.
Zinc thinks he's a know-it-all who can tutor us on our molar mass and volume chemistry homework.
I tried to explain to them that molar mass is the number with the decimal on each square of the periodic table, and I point out that this equals the number of grams per mole of an element, but Ruth thinks I'm wrong.
Not wrong. Just a liar. Or dumb. Or both.
Ruth, we've talked about your rudeness and name-calling.
Sorry, Zinc. I guess dishonest and ignorant would have been better word choices. Look here, Xenon. You told me way back when that the whole number is atomic number, which makes you atomic number 54, which means you have 54 protons in your belly.
54 protons in my nucleus, correct?
Yeah, I know I'm correct, 'cause I'm not ignorant like my ex-boyfriend Zinc.
Ex-boyfriend?
Uh-oh.
Ruth, can we talk about this?
Talk to the hand, Zinc. Me and Xenon are busy. Anyhow, Xenon, you told me the decimal is atomic mass units, which means if we put you on a scale, you'll weigh 131.29 AMUs.
More specifically, Ruth, it means the total mass of one xenon atom averages 131.29 AMUs.
Which means the total of your 54 protons and the average number of your neutrons equals around 131.
Yeah, I know, Zinc. I've been trying to tell you that this whole time.
But Ruth, that's not what our molar mass homework is asking for. The homework never mentions AMUs.
Yuri, molar mass is the mass of 1 mole of a substance, meaning a specific large quantity of particles, which means 1 mole of xenon atoms has a mass of 131.29 grams.
That's confusing. I don't think you and Ruth can both be correct. But don't ask me to take sides, 'cause you're my friend, Zinc, but I have to keep living with my sister no matter what.
You don't need to take sides, Yuri. Ruth and Zinc are both right.
So, Xenon, you and Zinc said molar mass is the decimal number on the periodic table. I'm uranium, and me and other uranium atoms have an average mass of about 238 grams per mole?
Correct.
I think we talked about this a long time ago. But remind me, Xenon, what's a mole in chemistry?
It's a gigantic number, Ruth. 6.022 times 10 to the 23rd power.
I wasn't asking you. I was asking Xenon.
Zinc is correct. The word mole simply stands for a fixed and very large number. You might say it doesn't mean 12, for example. Similarly, 1 mole equals 602 sextillion, which is several trillions, hence the scientific notation.
I can't even picture that. That's like all the atoms in the universe.
Not quite, Yuri.
Not by a long shot, my friend. 1 mole is the number of atoms or molecules it takes to create so many grams of a particular substance. Here's an example. An empty aluminum can weighs about 14 grams. Let's say that can is pure aluminum. Aluminum is nearly 27 grams per mole, so 2 pure aluminum cans would have a mass of about 1 mole.
Wow, that's a whole lot of aluminum atoms in those cans. And that also means there are billions and trillions and gazillions of other uranium atoms just like me in the world?
Uranium, you are unique, countless, and priceless, all rolled into one.
You can quit gushing over my brother now, Xenon. I just want to know. Our homework is asking us to figure out the molar mass of molecules. So there's trillions and trillions of molecules in 1 mole of those molecules. Am I right?
Absolutely, Ruth. Let's look at another example. Let's say zinc and our friend oxygen get together to make a molecule.
Oh yeah, me and Oxy did that just the other day. We made zinc oxide.
And what would the mass of 1 mole of zinc oxide be?
My average mass is 65.4 grams per mole, and the molar mass of oxygen is 16 grams. And I guess I just add them together?
Brilliant, Zinc.
That's helpful, but not all of our homework problems are that easy.
Like, here's one tough question. What is the molar mass of carbon dioxide?
Well, Carbon dioxide is made of 2 moles of oxygen for every 1 mole of carbon, so...
Ooh, I think I can do this one. The periodic table tells us carbon is 12.01 grams per mole, and oxygen is 16 grams per mole. But we have 2 of them, so... Anyone know what 16 times 2 is?
32.
Oh yeah, thanks, Zinc. 32 plus 12.01 equals 44.01 grams per mole of carbon dioxide.
Fantastic job, Yori.
This is a super tough one. It says, what is the mass of 2.5 moles of RuCl3? Wait, is RU me?
Are you me? No, I'm not you. Thank goodness.
RuCl3 is the formula for ruthenium chloride, which you can make with the chlorine triplets, Ruth. Why don't I walk you through it?
6.022 times 10 to the 23rd power of me equals 101.1 grams. Chlorine is 35.45 grams per mole, but there's 3 of them, so that means 1 mole of RuCl3 has a molar mass of 207.45 grams.
But the question asks, what is the mass of 2.5 moles of RuCl3?
I think you would just take your original answer and multiply by 2.5.
Think you're correct once again. Give it a try, Ruth.
My cell phone calculator says 518.625 grams.
Excellent job, Ruth. Do you think you and your brother are ready to finish your homework without my help?
Not yet, Xenon. There are also questions about molar volume.
Oh, that's simple. But keep in mind that molar volume only applies to gases. Just follow Avogadro's law. At standard temperature and pressure, 1 mole of any gas equals 22.4 liters.
I'm confused. I thought moles were different amounts for all substances.
Gas particles float and don't touch each other. The molecules spread out. Xenon's just saying that as gas molecules spread out, they fill a predictable volume.
Zinc, what gases are in those balloons?
The green one is oxygen in the form of O2 gas. The purple one is CO2. And the blue one is nitrogen in the form of N2 gas.
Oh, wait. How did balloons magically get into our closet?
Oh yeah, Zinc snuck them in here earlier. He was gonna surprise you.
They were going to be a gift for you, Ruth. But then you broke up with me, so...
Zinc, how many liters are in each of those balloons?
They all hold 11.2 liters.
Thanks. We're not quite at standard temperature and pressure, but we're close. 11.2 liters means each balloon holds half a mole of gas. As we can see, each balloon has the same volume, but if my math is correct, we could put each balloon on a scale and see they each weigh slightly different amounts.
But they're all the same size.
Wait, gas molecules are all spread out and don't touch. So yeah, I think I get it. Different sized molecules, so their mass is different, but the same number of molecules is in each balloon.
Oh yeah, molar mass, molar volume, it's all starting to make sense. Zinc and Ruth, I think we can finish our homework without you now.
No, wait, my sweet Winky Zinky Boo. Don't go, I'll miss you.
Are we good now, Ruth?
I could never stay mad at my Zinky, and I don't want you leaving with that super cute balloon bouquet.
Molar mass is elementary.
Yes, it is.
Now we see.
Check each atom on the table.
Periodic table.
We see that.
So simple.
Simple.
It's the number with the decimal.
Yup, it's fun.
Fundamental.
Molar mass for each element.
Yup, right there.
Message sent.
Bye-bye.
Wait, there's more. It's not just atoms.
Let's look at
Molecules.
Add your molar mass together.
simple mathel.
Not confused.
We've established that molar mass for each element is right there in black and white on the periodic table. It's expressed in grams per mole, and you can add molar masses to learn the mass of compounds. But let's review.
Remember, if you have multiple moles, multiply the total mass of the compound, and if you have partial moles, multiply by the fraction or percentage of the mole.
Now, do we need one final review of molar volume?
Sure, why not? As long as we can keep on singing.
Molar volume's elementary.
It sure is.
Now we see.
Easy.
Gases may make things look empty.
Yes, we know.
We can see.
See it?
Molecules are spaced
There's so
aplenty.
Filling space.
Now we see.
Tell me this, are you still confused?
Nope. Let's weigh
Molecules.
molecules.
Oh boy, that was fun.
Ring that bell thingy.
Join us.
Hit the subscribe button.
We would love to hear what you'd like us to focus on in future videos.
Let your friends know how wonderful we are.
Thanks for watching.